Hello students. In the last video we gave you an introduction to different ways to represent linear functions. So we're going to work on that and continue discussing that. So in this particular video we're going to start with an equation. So L equals 5k minus 8, and from that equation I want to complete the table, and then from the table I want to draw the graph. So this is a very common operation or set of operations that we do with linear functions. Equation to table, table to graph. So this is all fairly straightforward. All we have to do is substitute. So if k is equal to negative 4, I'll probably be doing these in my head. 5 times negative 4 is negative 20. Negative 20 subtract 8 is negative 28. Okay, when k is equal to 0, 5 times 0 is 0. 0 subtract 8 is negative 8. When k is equal to 4, 5 times 4 is 20. 20 subtract 8 is 12. And finally, when k is 8, 5 times 8 is 40. 40 minus 8 is 32. So now we've completed the table. The next thing we're going to have to do is draw the graph. Now notice I don't have a scale on my axes at this stage, because often the scale depends upon the equation that you're using. So if we look at the values of k, they go from negative 4 to positive 8. The top variable is always the horizontal variable, so I'm going to write a k on that axis, and therefore an L on that axis. So in this case, each of these squares could probably just represent one number. I don't like writing lots of numbers on this. I'm lazy and it gets a bit ugly, so often I just do 6, 7, 8, 9. Often I just do like every 5. And back 5, 1, 2, 3, 4, oops, 1, 2, 3, 4, 5. That's negative 5 and negative 10. So there's the values on the x-axis or the k-axis. Now on the l-axis, I have to go all the way from negative 28 to 32. So what I have to do is use a scaling factor here. So distance from there to there is 10 units. And from there to there is 10 units. So if I can't make each of those equal to 3 because I'm not going to get to 32. So I might make each of those equal to 4. So if I go 4, 8, 12, I might put a 12 there. Another 12 there. And another 12 there. So again, I don't normally put a number for each square. In this case, it seems sensible to me to do about every 3 squares. And of course, going the other direction, it's going to be negative 12, negative 24, negative 36. So each of these squares represents 4 units. Okie dokie, let's go ahead and plot the points. So negative 4, negative 28. So negative 4 is there. Negative 28, well, that's negative 24, and another 4, negative 28 is just there. 0, negative 8. So at 0, I go down to 8, roll down 4, down 8. That's that point just there. 4, 12. I go across to 4, up to 12. And finally 8, 32. So I go across to 8 and up to 24, 28, 32. And if this is a linear function, all of the points should lie in a straight line, which they seem to do. So now I can go ahead and draw that line. I think I'll make the line red. So starting there, and I just draw the line that passes through all those points. And I can extend it. No, that's not real good. I can extend it And that's about the best I'm going to do in the opposite direction if I want to. It's a lot easier if I had a ruler here, but I don't have one. So I started with the equation. I then went and filled in the table. Having done that, in this case I put the numbers on the axis, plotted the points, and because this is an example of a linear function, all the points lay in a straight line. Okay, let's have a look at a practical example. Lisa, a travel agent working for an airline, receives a base wage of $160 each week and a bonus of $40 for each flight that she sells. So we're going to start by filling in the table and then filling in the graph. Then we'll go back and figure out how to find the rule. So I'll go to my gold pen. Okay. The number of tickets sold in a week is N, so that's the variable on the horizontal axis. The weekly wage is W, that's the variable on the vertical axis. Now, if she doesn't sell any tickets in a week, has a really bad week, she still receives her base wage of $160. If she sells one ticket, she gets an additional $40, which brings that up to $200. If she sells another ticket, she gets an additional $40, which is $240. Now, once again, these numbers are going up by 1 each time, and these numbers are going up by 40 each time. So that's going to be 280, 320, 360. And working out how much the Y numbers, or in this case the W numbers, change when the X numbers, or in this case the values of N, change by 1, turns out to be useful when we're trying to find the equation or the rule later on. Okay, let's go ahead and plot these points. So again, that's the X coordinate, that's the Y coordinate. When X equals 0, so the number of tickets sold is 0, she still earns about $160, or earns $160. So to approximate that on the graph, a bit above 150. If she sells one ticket, her wage for the week is $200. If she sells two tickets, it's $240. If she sells three tickets, it's $280, so that's roughly about there. If she sells four tickets, it's $320. And finally, if she sells 5 tickets, it's $360. Oops, let me see if I can get that fairly accurate. And once again, because this is an example of a linear function, all the points will lie in a straight line. Okay, let's go ahead and draw the line that joins those. I'll go to my red tool for that. Whoops, I don't think I've got my pen tool for that. In red, let's try that again. That looks a bit better. And I'll try to carry that out further. It's going to be something like so. Okay, that's probably not perfectly accurate, but it gives a pretty good idea. So once again, we have a linear function because the graph of this rule is a straight line. Okay, the last thing we have to do is to find out what the rule is. Well, we're trying to find the weekly wage based on the number of tickets sold. So the rule is going to be, got to get to my writing tool now, weekly wage W, and I want that to be gold. The weekly wage W. Now once again, when she doesn't sell any tickets at all, then she still earns $160. So that's the constant. That's like the starting value. Even if she sells no tickets, she earns $160. For each ticket that she sells, her wage goes up by $40. And of course, that comes from there. And it also comes from the fact that these numbers are increasing by 40. So for each ticket she sells, she earns an extra $40. And we can show that in the equation by saying it's 40 times the number of tickets sold plus the fixed amount or the base wage. Let's do a quick check of our rule. Let's again pick n equals 3. 40 times 3 is 120. 120 plus 160 adds up to 280, and it does check. So this time we started with a word problem. So there's the way the equation is expressed verbally. From that, we completed a table. From the table, we plotted the points and drew the linear function that passes through the points. And finally, we then went ahead and found the equation or the rule. Okay, so the next video, we're going to continue with this same idea of looking at different ways of writing linear equations.